All right. So Phil Chung is a director of product management at Oracle, responsible for planning, strategy, and helping build an enterprise cloud native Java with GenAI Kubernetes platform. Formerly an Oracle Cloud Infrastructure Cloud Architect and member of the Oracle Financial Services Global Industry Solutions Group, Phil has expertise in software architecture and development focused on Java-based real-time, in-memory data processing, in-memory data grids, and middleware. Phil's expertise includes a combination of deep capital markets, telecom, gaming industry, and technology. I first met Phil last year at the Oracle event that was in New York, and then I saw him just last week at the other Oracle event. And I'll let you tell the story how you couldn't get in right away. So, and anyway, folks, thanks for your patience in getting started late and our technical difficulties. So without further ado, let's give Phil a warm welcome.
Thank you. Whoops. There we go. Let me just put this in presenter mode. Where's my, I gotta look for my mouse. Where is this? Where'd it go? Where is my mouse? Okay. Where did my mouse go? Oh, there it is. How do I swap? Where did I swap? Hang on. Let's try this one more time and just try to figure out there we go. All right. So thanks for coming by in this rainy day. Yeah, so just real quick, I'm part of product management. Our group is Enterprise Cloud Native Java. We focus on the intersection of Java and also with Kubernetes and AI. I have my social media links there. And so we'll go through like an introduction of RAG, what it consists of, and I'll also talk a little bit about one way to implement it, a cloud native RAG solution. And if you have not seen these products, the Helidon and Coherence, they're open source products. They're on GitHub, and they are developed by Oracle. And there is commercial support for both of the products as well. But I wanted to show you like some of the technical reasons why you might want to take a look at it a little bit further. It just, everything, if you look at all the AI in the newspaper, the GDP impact of it, according to a couple of different analysts, they range from 2.6 to 4.4 trillion. It's a lot. One of the venture capitalists, Stephanie Zan, she had a TED Talk, and she asks all of her AI startups, or basically any startups, what is the scale of your ambition? And all the startups have to have some type of AI incorporated into their business model. And the reason why is that AI kind of amplifies the effect, and amplifies the growth. So all of the VCs are looking for that, and it's always growth. Yeah, all the big tech. An example of some of the things that are being built today, NVIDIA has released an LLM for the first humanoid robot brain, Groot N1, and they're looking at it as a first multi-trillion-dollar industry. The other things that they're working on is a distributed execution of CUDA, and they're planning that for 2027. So, if you look at it from both perspectives, they're trying to do this from, running an LLM at, as close as possible to, to the edge on small devices, and also at the data center trying to scale this out. So really scaling this from extremely small language models to also extremely large language models as well. And that's why, we see cloud vendors and they're trying to build, cloud services and everything, but there's also the edge of cloud. And that is actually positioned most to benefit most from the explosion of open source LLMs, right? It's been commoditized, and one area that we see is if you look at the news, so tariffs are also one way that open source LLMs are very popular because it incentivizes companies to have a stable outlook on building out their AI solutions. So they're incentivizing vendor and country neutral solutions at the edge where they can locally host it and manage it themselves. Okay. If we're looking at it from a technology perspective, there is a lot of work being done to facilitate AI with Java. If you go on YouTube, there's actually a video from Java 1, 2025, Paul Sandoz. If you search for Java and AI, that session should be there today. It's been out, I think, for about a week or so. And it kind of details some of the work that the Java platform team have been working on to improve the interoperability of Java and AI. Everything from going to small scale, let's say robotics and drones at the edge, and all the way up to a distributed runtime for the AI data center, right? There's certainly a lot of opportunity. So if you look at it from a VC perspective, startup perspective, there are definitely a lot of workloads that can benefit from the combination of Java and AI. And that's why I mentioned it's modular, portable, and very powerful when you combine the two. If you want to call out some of the different types of industries and systems that could benefit from AI, there's certainly anomaly and fraud detection. Everybody, does language translation. And certainly when you start looking into vector databases and semantic similarity search, you start getting into recommendation engines. Certainly, most people, use Spotify and, things like Netflix. They have recommendation engines, and they use similarity searches, right? So just, didn't want to belabor the point, but there's a lot of systems that if you look at web companies and web startups, when they grow up, they actually tend to become Java shops and Java companies. So that maturity will show given the fruits of our labor with Java and AI. So moving on to one of the things that AI, one of the challenges is to make it more accurate and to reduce the hallucinations. So one approach to do that is RAG, Retrieval Augmented Generation. And it's not just doing it once and you're done. I guess the benefit is to actually do this RAG process quickly enough so that you can iterate, you can change some of the parameters, you can improve the RAG process, and you can do it faster and faster. And the reason why is you also have to keep it up to date, because if you look at things like OpenAI, the cutoff date for the training is usually around end of 2021, September 2021. So anything that is past that point, you need additional fine tuning. You need RAG, for instance, to keep it up to date. So you constantly have to run this RAG process or RAG application to keep that up to date. The other areas that people explore with RAG is really from security. They want to keep this in-house and manage the LLM themselves. So it's a security and privacy issue. And certainly training a LLM is very cost prohibitive. I was talking to an internal team. They were going to do a pre-training in LLM with some of our code bases, internal repos. And it'll take weeks to months, right, to get a fairly small LLM fully trained. We we have an army of GPUs for our customers, but for internal projects, we don't have access to like 10,000 GPUs that we have at a moment's notice. So the cost to train generative AI is quite prohibitive. But with RAG, I'll show you a way to do this with commodity GPUs. So if you look at it from a diagram, the normal ChatGPT application, you send it a question to a chatbot, and it asks the LLM, and it gets a response, and that's without RAG. So with RAG, there is a process where when you ask the question, it will also do a semantic similarity search to a vector database. That's on the right there. That similarity search will fetch the words and the tokens that are close to that topic that you are asking, and it will retrieve the chunks of information that is associated with those tokens, send it to the LLM, right, as part of the question as well. So that's step 4. So the model will take that context, really, that the chunks of information that you have put inside the vector database, and it will take that into context and return back a response to you, right? So that is the high-level RAG approach. If you delve a little deeper in it, you have a serving engine, which is basically your web server for your chat application or AI application. The inference is basically your LLM. The vector database is where you would be storing or ingesting your additional information into your application. And that additional information could be PDFs, text files, and it could be multimodal, like media ingestion as well. So you need to have a way to fetch this data, right? It could be a flat file, it could be a document store, a document system. So you need to have a way to pull that up, and as part of that process of RAG, that what's called embedding engine will translate those documents into floating point numbers. And those floating point numbers are effectively your vector embeddings. And the vector embeddings are an array of floating point numbers that allows you to set coordinates, right, for your tokens. So when you do a similarity search, I guess I should probably forward my slide a little bit, make it more visually understandable. So when you do a vector embedding, what is actually happening is your RAG process has to pull in the documents. It has to do some computation. That computation is to calculate effectively a set of floating point numbers or vector of floating point numbers. And these floating point numbers, you could think of them as coordinates. In a vector embedding model, it's not two-dimensional, it's n-dimensional, right? So we could be talking about 100, 200, or a few hundred different dimensions. So it has to calculate those floating point numbers think of them as coordinates, and those coordinates determine how close a certain topic is to what you were asking. So in this example, you could have asked it something about a fruit, and because of the model that you might be using, that will group the set of fruits together. it'll group other like things together. And those coordinates means that they will be clustered fairly close together. So that's really vector embeddings. So you have to have a way to calculate those vector embeddings. And this is what is used in a similarity search, a semantic similarity search. So the embedding process, which I briefly described, you need to have a way to retrieve the documents, right? Either locally or in the cloud. So there has to be a way to download it. There has to be a way to store it. And as part of the RAG process, you read those documents and you split it up into chunks that is easily digestible as part of the RAG process. That chunk gets tokenized. So a word can be associated with a token, right? We use the word token because if you use a multimodal, let's say music or graphics, video or images, a token does not necessarily mean a word, right? So you tokenize it. So if it's a document, a token is a word. You break it up into a vector of text, and the vector database will calculate the floating point, the vector of floating point numbers. So that's the embedding process that is done by the vector database. Now, the second part of the process is to query it. So in this process, you would do a semantic similarity search, meaning you could ask, let's say, something about grass, and it could bring back, let's say, a topic around lawnmowers, right? Something about fertilizer, something like that. So the words are not similar, but the topic is similar, and that will depend on how you calculate the coordinates for the vector embeddings. So you get the similarity search, and it returns back the set of tokens, and from those tokens, you can retrieve back the document chunks that are associated with those texts, and those chunks you can send it to the LLM, right? Whether it be ChatGPT or any llama or anything on Hugging Face. It's a repository for all of the actually a lot of people ask like how many LLMs are there? Do you guys know how many LLMs are on Hugging Face? There's over 1 million. There's over 1 million. It's not just like big ticket names that you might recognize. It's all derivatives of that are trained for a specific thing. So there's over 1 million LLMs on Hugging Face. So this is RAG. After the embedding, you can see the first step. You ask your chat application or AI application. It will ask that same or translate that to a similarity search to your vector database. It will get the results of that similarity search and get the chunks associated with those tokens and send those tokens. It sends the chunks along with your question to the LLM, and you will get the response back, right? So that's at a high level, that's RAG, right? And I think there are so many different solutions out there for RAG, both open source and commercial. But we wanted to show you what what our team have built around a cloud native RAG. And with Helidon, if you haven't heard of it, it's an open source cloud native microservices framework. And Coherence is a in-memory data grid. And I'll explain how they work together as part of that RAG process. So what I just described with the anatomy of RAG, both of these components, which are on GitHub and open source, they are used for a RAG application. So in order to describe Helidon, I wanted to show this slide in some of the technical reasons why we chose Helidon to develop this RAG solution. And with Helidon, we were using it as a way to rethink microservices and also AI agents in general, in that Helidon was built from the ground up to leverage Java Virtual Threads, which was released in Java 21. So one of the things that Java Virtual Threads is good at is it's very high throughput. It can scale very well, and it's really meant. If you look at it in the perspective of a developer, when you think of microservices and you're trying to build something very scalable, very fast, very high throughput, most of the frameworks out there, they all depend on reactive or asynchronous coding underneath, right? It doesn't matter if you want like very high performance, it's usually reactive or asynchronous coding. The problem or the challenge with that type of framework is the complexity behind reactive coding and the poor debugging experience that you get from that. So with the complexity with reactive coding is that you always have to set up callback handlers. And the challenge with that is once you start making a lot of callback handlers, it's hard to follow your code. It's non-sequential at that point. It just goes all over the place. So we call that either callback hell. Another name I've heard is pyramid of doom, because all the indents look like a sideways pyramid, right? And the challenge also is when it is very complex to debug. When you try to look at stack traces, they also don't flow linearly, and you cannot step through it in a traditional debugger. So all of these issues kind of convalesce into CVE vulnerabilities, bugs, and this was the baggage that we wanted to avoid. If we were trying to do everything right from the ground up, and we're trying to do, let's say, if you had to rewrite everything, or not, let me back up. If you wanted to do things from scratch, and you wanted to do it the right way, right? We wanted to have a way to reduce and eliminate technical debt, right? And this was the baggage that we wanted to eliminate with microservices and with AI agents as well. So reactive Java, in essence, is really a trap. Like Brian Getz had already mentioned with Java Virtual Threads that he feels that it will eventually replace reactive coding. Just a little bit of history here. So Helidon had earlier versions, major versions 1 to 3, and they leveraged a reactive core underneath. It was using Netty. I'm sure you guys know Netty. And there are different ways to certainly leverage and get the benefits of platform threads, but using reactive. And the reason why everybody had to use reactive was that there was a cost associated with a thread, with sockets, with having those resources open. If you look on the bottom over there, I didn't know it was that blurry over here. If you guys can see the words on the bottom here, the memory overhead for a platform thread in Java is on the order of hundreds of kilobytes to megabytes, which meant that your concurrent upper bound was in the thousands. If you look at other technologies, Golang had Go routines. The overhead for a concurrent Go routine was a few kilobytes. So the concurrent upper bound was hundreds of thousands of concurrent tasks. If you look at Java Virtual Threads, the overhead is a few hundred bytes. So it's an order of magnitude improvement. So the concurrent upper bound for concurrent threads with Java Virtual Threads is millions and millions, right? So with Helidon 4, we got rid of Netty, and we used a native virtual threads approach to dealing with to dealing with sockets. So I guess the high level is you get the scalability of reactive, but the simplicity of a thread per request, right? And at that point, you can follow your code. You can use for loops and while loops, and you can step through that, and you can visually see where your code goes. Your stack traces now work as advertised, and your debugger, you can step through it as advertised in your standard debugger. So this actually clears up a lot of things. Since I believe since 2019 or 2020, there were 19 CVEs with Netty alone, right? So we're trying to not just improve throughput and performance, but also improve readability and security. So Helidon in general, it's an open source framework to building microservices and AI agents as well. Yeah, container and Kubernetes and CNCF friendly. It is, as far as I understand it, it's still the only framework to implement virtual threads from the ground up. You have other frameworks, right, that kind of retrofit virtual threads, but they don't get the benefit that you get from Helidon, and I'll show you in a little bit. So it is very friendly. Its ability to scale the same way as reactive asynchronous code, but you get the simplicity of the thread per request. But you also get the ability to write and understand and maintain and debug clean code, right? If you compare it, and certainly Spring Boot, you can retrofit with virtual threads, but you don't get the benefit of that in the sense that you don't get the scalability in terms of the lower memory usage and the footprint and the time to the throughput and the time to first response. So, it's something that we're trying to work very closely with the Java platform team to ensure that you get the most benefit out of the technologies of the Java platform team. So, sorry, just a little bit of an intro and understanding of what Helidon is and why we used it as the foundation for building stuff for AI and to build AI agents. So in the latest release of Helidon, it's 4.2, and I think we had 4.2.2, and I think right now it's the latest release. We also have integration with a library called LangChain4j, right? It's the best-in-class AI framework for Java. So LangChain4j has some nice features in that it can abstract certainly the various LLMs, the vector stores or vector databases, including the Oracle database 23AI. You can use as a vector database, and you can also use coherence as a vector database. I'll explain why you might want to use coherence. But the LangChain4j, we have a special integration with that in Helidon, in that we've included a couple of annotations to help configure it. So there's actually a focus on making it easy and consistent to write Helidon applications. Essentially, the cloud native microservices and AI agents for it. The LangChain4j integration also provides you the way to manage chat memory and also to do function calling. I'll explain what function calling is. But if you look at a diagram filling out the words of what we had seen earlier with the RAG process. So the serving engine could be Helidon, right? Effectively, that's the web server providing the chatbot interface. And that can be, the LLM could be a local LLM, right, at the edge. It could be something that you manage. It could be an external service, whether it be ChatGPT, or it could be a cloud service that, Oracle Cloud also has a GenAI service in the cloud. And the vector database, it could be, anything out there. We've tested it with coherence, Oracle, but also MySQL, Postgres, OpenSearch, other vector databases. and at the persistence level, you can have some kind of document store. It could be flat file, a bunch of text files or PDFs. So, and the thing with coherence is that the vector store can be done in a massively parallel way. So you could scale this to a lot of CPUs and GPUs if you had. But that's one of the secret sauce reasons why you might want to use something like coherence as the vector store, because of its very easy way to scale out. Let me do a quick demo here. So this is the LangChain4j documentation over here. We've actually incorporated Helidon, so it actually shows up in two places. Under integrations, frameworks, you'll find Helidon there. See? And you can see that the key things are it has integration with the annotations within Helidon. There's convention over configuration. So we're trying to simplify the configuration. They have declarative AI services for that and integration with CDI, context and dependency injection. So you can use Helidon as the way to use it with standard Java applications or as part of a standards compliant microprofile or Jakarta-based CDI application. The other area that there is documentation is in the tutorial. So, whoops. So under tutorials, there is Spring integration over here. So under the tutorials, you can see that we have samples for, there are two flavors. So Helidon Standard Edition and Helidon Microprofile. And I didn't get a chance to explain what the two flavors are. So Standard Edition of Helidon, and basically Helidon is very modular. You can use it, we make very judicious use of dependencies. So if you don't want to use things like annotations, you don't need to do things like GraphQL, that's fine. You don't have to include it in the dependencies. If you wanted to have more of the capabilities that have been standardized in microprofile, Helidon has a microprofile flavor. So microprofile incorporates the standards for CDI, the context and dependency injection annotations, has support for JAX-RS, for REST, and for JSON, fault tolerance. There's a standard microprofile config that's been set by the Eclipse Foundation, but it's still very small, right? Let me just go through here the standard edition really quick. So let me just go through the source here, just show you really quickly, and I could show you running the application. Let me just expand this all. And you can run this, right? It's all the samples over here in LangChain4j. Let me just go up a bit. So the LangChain4j examples here, let's see. Yeah. So it has the quick README over here. It shows you how to build it. It's very easy. Just two Maven commands. You have to build it, and you just run it, right? Well, just with the Java command. So the main application here, you can see where it starts. This is just the standard application, standard edition, I'm sorry. So you can see that it uses Java builder classes. So services get, ingest. So this is where it's ingesting something for this application. So it's doing the RAG ingestion. So let's take a look at that menu ingester, menu items ingester. Oh, I'm sorry. menu items ingester. So it's using a combination of the Helidon APIs and the LangChain ones. So there are some annotations that they're a part of Helidon Inject. They're much more lightweight than CDI, and that was introduced in Helidon 4.2. And again, you can use them, or if you don't want to use them, you don't have to use them, right? And your application could be smaller. So in the ingester, we have defined an embedding store and embedding model, right? So as part of that, there's a configuration, again, with Java builder file, builder classes. And the ingestion process, right? There's an ingest method. You're passing in the embedding model and the embedding store. The embedding model is what is defined. There is a YAML configuration file. Let me show you here. Let's try. Let's try to. Let me try to move this. Oops. Yeah, you can ingest data into Coherence as well. I don't have this this is a simple demo that's on GitHub, but so there's one line that you can change. So the embedding, sorry. Can you guys see I'm trying to increase the font size here. Let me just, whoops. I'm trying to find a way to move this out of the way, or maybe I can, hang on, just, yeah, I get that a lot. I was trying to move I was trying to move this down a bit so that I can see where I'm clicking. Okay. Is this readable? It's a little better. Yeah, so Boris, you're asking about coherence. So there is one line that you can change with so the embedding store. So that's an interface from the LangChain4j library. Coherence has implemented that interface. So you can, with one line, just swap out. This is just the default the default embedding store that comes with LangChain4j. It's just a simple,
Follow-up question to that is, why would you want to do that? I mean, you want your embeddings, I mean, your ingestion store to be persistent, and here is a distributed in-memory cache.
Yeah, so the two reasons.
To the use case, I guess.
So there are two reasons why. So the use case is you're using coherence to quickly parallelize the computation of the vector embeddings to floating point numbers. We can scale this better than anything out there that we've seen. The other, so with that, once you've calculated that, yes, you need to store that somewhere. So you could store that within Coherence itself, and you can optionally persist that just with Coherence. Coherence has persistence capabilities, or you can write that as Coherence can be used as, think of it as a very fast write behind cache. So you do the calculations very quickly in parallel, and then you use, let's say, 23AI as the database to write the vector embeddings, or some other permanent document store, right? So, yeah. So the embedding model is, yes. So the embedding model can be inside Coherence. So Coherence is doing the calculation, doing the floating point. That maxes out the CPU or GPU. And what we've seen is we had a internal POC with a team that had to ingest all of the Oracle public documentation PDFs. So all of the documentation for Java, coherence, WebLogic, the database, all of that stuff. That's 1.8 million documents, right? And we had an internal team that was developing a custom Python solution using GPUs in our cloud. It took them 40 hours and 8 minutes to calculate that with their in-house solution. They tried using coherence. We were able to scale out just using standard CPUs, not GPUs. So we're competing with just commodity GPUs. This was with the AMD EPYC it was our E4 shape in OCI. So that was the I think Gen 3 of the EPYC chips. It got down to, well, we could scale it. I'm trying to remember the numbers. I believe it was 36 nodes. Each node had 10 OCPU. So 360 OCPUs, essentially. And that got down to 1.5 hours. So from a cost perspective, right, the GPU, it was like 40 CPUs and 2 GPUs, I believe. Well, 2 of the, I forget what the NVIDIA ones. So that the cost for that was $160 on OCI. The cost for the coherent solution was $15, less than 15. And it's a constant. If you wanted to, if you didn't have, let's say, 36 nodes or 360 cores, if you cut that in half, it's still $15, but it would just take double the time, right? So you have a fixed cost with that scaling, right? But this gives you optionality. This gives you the option of saying, I have access to a lot of CPUs or GPUs. I want to do this as fast as possible. Go do it. And then I can figure out if there's a way I can optimize it. I can change some of the parameters. I can try again, because you're going to need the RAG process again for, let's say, if you have living documents in your corporate network and your Confluence and wiki pages, you're going to need the RAG process again, like, either tomorrow or a week from now or a month from now. So the ability to iterate quickly to improve upon this process is important. If it's going to take you 40 hours to do it, then you're not inclined to iterate as quickly as you can. So let me kind of go through this really quickly. So the embedding model here, as I mentioned, you can swap it out, one line of code change to coherence. So this will ingest, there's a document, and I was going to show you I was going to try to move this. So there's a document data. Where is this? I have to go up. Where do I get the... Trying to figure out how do I get the left-hand side panel back. Oh yeah. Oh, thank you. Yeah, so there is here. Well, this is the application YAML file, and this is the configuration that you can use so that you could swap out, let's say, the model and also the embedding store. You could specify that and other parameters as part of the RAG, right? So this is a fairly isolated way that you can use with coherence. With Helidon, so that you can quickly change out things and easily make these changes. there is a JSON file. I'm trying to figure out where I'm looking for that here. Where did I have the JSON file? Data menu. Oop. The JSON file. I thought it was here. I should have thoroughly checked this. I was using IntelliJ before. I figured this would be more lightweight when I was running Zoom and all the other stuff, because I've limited memory on my laptop. Yeah, there should be a JSON file I wanted to show you.
Where it says Helidon -4x, does it go to?
Oh, here, data. Yeah, here it is. I'm sorry, here it is. So this is the document file that we used for ingestion for the RAG process. So this is an example of a coffee shop. So let me run that. Hang on, let me try to. Trying to figure out where's my where's my doc? Where did my doc go? I was trying to run my terminal. There we go. I don't know where my doc went, so let me just everything works differently when all this is on Zoom. Interesting. None of my command shortcuts work. But anyway, this is in the directory that I got the example from, the coffee shop, and you know, I'll just run the example here. Here's my I don't have my doc. None of the shortcut keys work. What's going on? So let me try to find my browser. Where did it go? Where's my browser? Okay. Okay. Apparently, when I go full screen, something goes unexpectedly. Okay. I'm trying to move this so I could see what I'm typing. Okay, so let me. Okay, so let me copy this. I can't see what I'm typing. Okay, why can't I move this? I can't see what I'm typing. Yeah, that's why I can't I can't see what I'm typing. Yeah, I don't remember. Okay, so I'm able to see what I'm typing now. So what drinks do you have with matcha? Let's So, okay, so it has it sent back a response, and let's say, okay, how about I'll take one. It's like, you can see that there was a new order that was created in the application. It says, this is my order ID. Would you like anything else? So an order is created. Now, in the application, the order was used. Hang on. It's all right. So there is, let's show you the order and what was used in that. So there's a chat AI service. This is the prompt. So you can define a system prompt. It says, and that's to help direct the LLM to say, "You are Frank, a server at the coffee shop. You must not answer any questions related to anything other than making drink orders." And you use a save order callback function. So in LangChain4j, there is the concept of a function callback. And a function callback is pretty cool. You can annotate basically your application to have a method that is available to the LLM to call back to do certain things. Let me find. Is chatbot, or I need the. It's easier for me to the order service. Here we go. It's hard to. So there's an annotation here, and it's the tool annotation. So with this application, what this tells the application, this description is written in plain language, plain English, right? And the LLM will read this description, and it will decide when to call this. So if you have an application that needs to call out something as simple as a calculator, something as, let's say, saving an order, right? You annotate it. Optionally you can annotate it, or you could use a builder class. It's easiest if you use an annotation, so that's why we have an example here. So you tell the LLM, this is the method to call when you need to do something, XYZ. And also, make your parameters easily understandable, right? In this example, order items. So the LLM at this point, when you saw me do the chat, it said, I said, I want to order one. And it went ahead and called this method, and it created this new order, right? With this order ID. And that order ID was generated by this method right here. So it's pretty powerful. Once you start thinking about it, there's a lot of things that can be done. Why does it cover everything? How do I move this out of the way?
Ramp it upside. It's a rectangular bar,
Yeah.
white on black.
How can I?
Funny thing is, you can't really see it.
Yeah. I how do I? Yeah, I don't remember. Just give me a second. Let me stop sharing so that I can I can see what I'm doing without this thing in the way. Slideshow. Okay, and then let me share again. These are all the technical difficulties you don't encounter when you're testing at home. Okay, so I have a bunch of stuff on the code, but really you don't have to, I'm not going to go through all the stuff on the code. You can read it on GitHub, but this is the basic chat example here. The tools functions is very cool, and this is the foundation, the basis for AI agents, meaning the ability to do something in your code, to do something in your system, right? An example of that would be a calculator class that you can define with the tool annotation, and you can say, this will calculate something. LLMs, when they first started out with ChatGPT, they weren't very good at math, and it's by design. If you want it to be good at math, you can set up a AI agent with this tool annotation and just do a calculator, right? That's really the best way. And if you think about it in the context of multiple agents, you can have another agent, let's say a web search agent, right, that calls out and does a web search. You can combine that together, right? When you have multiple agents, this is the whole AI agent, ecosystem. If you ask the question, what is 7 times the length of the Grand Canyon, right? So it can do both. Call 2 agents. It will do a search to figure out what is the length of the Grand Canyon, and then run the calculator, run 7 times or a square root of the length of the Grand Canyon, something like that, right? But that, if you think about it, that's very powerful. At that point, you have multiple agents with multiple endpoints that you expose to the LLM. At that point, your code is non-deterministic. The LLM will determine when to call those tools. It feels weird to have non-deterministic code when you think about it. But yes, this is just a comparison of if you had to write straight OpenAI in Java, this is what it would look like on the left. And LangChain4j kind of helps abstract a lot of that stuff out for you, so you don't have to do that. This is an example of it switching to Ollama, so you don't have to use OpenAI. So LangChain4j does a lot of abstraction for you. It's very easy to use. Makes it easy to swap in and swap out LLMs and vector databases. It's got a lot of stuff for RAG as well. LangChain4j right now is at release candidate 1 for version 1.0. We expect it to go 1.0 this month sometime, right? So, and we're working closely with the LangChain4j community. So the Helidon team, we built a couple of things. For instance, the Helidon inject. So there are specific annotations for the LangChain4j integration. We have convention over configuration for some of the key features for LangChain4j to make it easy to swap in and out different components, to have declarative AI services. And we also have a bridge to CDI. So in case you wanted to use in your application CDI, JAX-RS, some of the standard Java APIs and specs used. That's in the next release with, we plan to have MCP server, and you can swap out the MCP client also to any HTTP client that you want. That's part of the design of LangChain4j, swap out the client. The current implementation in LangChain4j is Apache OK HTTP. Some people don't like that. So you could swap out, whatever you want. So, and we expect it, and that's the plan for Helidon 4.3. And there'll be more things with AI, not just MCP, and so stay tuned. There's a lot more stuff. So with Helidon AI, the integration I showed a little bit before is with the standard edition, you have an application YAML. With microprofile, there's a microprofile config YAML file. YAML file. So we're trying to make it easy to use, and we're trying to make it consistent with the Helidon programming model. How to use the tools annotation, for instance, over here. You define the AI.service and the tool. You could also leverage that from LangChain4j. Switching the models, going from OpenAI to Ollama. It's very easy to do. With the embedding, if you need to use it with RAG, we also separate out the RAG configuration. You can see that in the application YAML I showed earlier. And the embedding models, you can see the what we use here. This is the kind of most people use this for vector embedding for RAG. This is the All-Mini LM embedding model. You could get that on Hugging Face. And as I mentioned before, the in-memory embedding store, this is what comes out of the box with LangChain 4j. But if you want something that can parallelize and scale to 1.8 million documents, right? We've tested this internally, and it works really well. And in terms of ingestion, you can ingest like PDFs, text files. You could also use Word docs, and basically anything that you might want to ingest in Java. Let's say you could do other multimodal stuff as well, and you start going into music files and audio visual. You will need some way to ingest that, right? So out of the box, it does text. There's a bunch of high-level AI design patterns that we want to facilitate with Helidon. And these, there are 4 categories, and these were kind of coined by Professor Andrew Ng. He's a Stanford professor and kind of AI pioneer. So some of them are reflection, which is in your prompt, you ask the LLM to kind of review its own response and see if it can improve on it based on different parameters, based on different viewpoints. You can use this, let's say, in like financial record from a risk perspective, or did you think about it from a growth? And you can kind of use reflection to kind of modify its response. Tool use is what we saw in having the LLM decide the API to call to an external system or data source. Planning is when you have a complex task that you need to break down into smaller steps, and you need to go through that one at a time to execute. And then the most complex use cases when you have multi-agent and multi-LLM, you need to collaborate on that. An example is what I mentioned before. When you have multiple agents, let's say an agent for web search and an agent for a calculator. So that's multiple agents, but then you might have multiple LLMs. When you think about it, you might have a specialized LLM for, let's say, a medical care recommendation, and another LLM for billing and fraud detection, another LLM for image and video generation, right? Those are all specialized use cases, and you might want to have, multiple things. And that follows the philosophy of Unix having small services, and that's also the philosophy of microservices. Going on a slightly different tangent. So I had mentioned coherence, and I tend to think of it as a jewel in Oracle's middleware stack. Coherence also has a community edition. I mentioned it's on GitHub. It's open source. We have commercial support for it with coherence licenses. For those that don't know, it's a in-memory data grid with optional persistence. It has automatic sharding and automatic fault tolerance by default. Yeah, and there's a lot of things that you can do with it, not just the distributed cache, but if you think about caching, it's moving data to where your processing is. There's also the concept of moving the processing to where the data is, right? Sometimes I call it inverse of caching. The interesting thing is like other companies, also use inverse of caching in a different definition, but it's the way that I think of it is when you're moving the processing to the data, and you have a way to, at that point, you have a way to parallelize massively and to scale that horizontally. At its core, coherence also is an event-driven architecture. And you can query it, you can aggregate, so you can do stuff, you know, in REST management as well. You could do aggregation, var aggregation. So in general, it's very fast, scalable, fault-tolerant, reliable. It works with multiple sites. You can have coherence run in Kubernetes as well as a Kubernetes operator. It's cloud native and cloud ready. And there's also different languages that it supports as well. So not just Java, C++, and .NET, but we also have clients for Go, Python, and Node.js. And there's a REST API, there's a GraphQL interface to it. There's REST, management as well. There's JMX mbeans, and you can also get metrics via OpenTelemetry. And the older one was OpenTracing. So coherence AI, I tend to think of it as a new dual facet to coherence. There were two major things that were added to it. One was doing the calculation and the storing of vector embeddings, right? And the other, that's really ingesting the documents. And the second aspect of it is the semantic similarity search. And we can do that. We could do both in parallel. So they're both massively parallelized in coherence. And this facilitates a couple of different use cases, not just RAG. So the RAG process is one use case, but with any similarity search or any vector database, you could do recommendations, anomaly, and fraud detection. At that point, you can figure out edge and image and object detection and classification, and certainly with pattern analysis when you do the similarity search. So it facilitates a lot of different things that opens new doors to do a lot of these things with coherence. The thing that I mentioned earlier with RAG is that we built a system using coherence and Helidon to do that massively parallel RAG. I mentioned, the 1.8 million documents that we ingested, and it's scalable. And doing it with RAG, it certainly, you see the maxing out of the CPUs. So in that 1.5 hours or 3 hours, if you only do 18 nodes, the CPU is pegged. So at that point, we are ensuring that there's a minimal amount of single point of bottlenecks. So that's really what coherence is trying to provide, it's scalability software. We're trying to ensure that you can horizontally scale linearly. And some of the features that we're using to implement that, right? And the cache stores. So we can do this computation, the vector embeddings, and we could also store the document chunks, or you can asynchronously write that back to your document store, such as Oracle database or MySQL or Postgres, whatever document store you have. You have a lot of different features and functionality. I don't want to read through the slide. And I'll share the slides with you guys. If anybody wants, I'll give them the mic. So the architecture, Helidon is providing the REST API in a very scalable way, as I mentioned, with virtual threads. Coherence is doing it also in a very scalable way to do the vector embedding. We're using LangChain4j to do that abstraction of the LLMs and the vector stores. And the Onyx runtime is actually used to do the vector embedding, to run the vector embedding model. So in a single member and across a number of clusters, nodes in a cluster, and this will linearly scale. So let's do I could do a quick demo. Where is my doc? Oh, I'm looking for Safari. Okay. All right. So let me I believe, let me reset it because I wasn't sure if I had, so let me just put in the API key for OpenAI. And so this is kind of like the UI for ChatGPT. In the, in the interest of time, there were like pre-generated questions, and yeah, let's take a look at went wrong with, let me probably refresh. Let's see. Probably my session died. Okay. Okay, here we go. So with ChatGPT, either, this is 3.5 or 4.0, the cutoff date in the time is end of 2021, right? And we're trying to think of questions that were after that date. So at that point, it would kind of have to work to struggle to figure out. And if it doesn't have the right information, it's just going to hallucinate or confabulate, as Frank Greco usually likes to correct us. So with the RAG solution, what I can do, I can load up the documents for the coherence RAG. Let me see, is it running? Yes, okay. So what's happening now is that I am ingesting the documentation for coherence and WebLogic and the database. I believe that's 206 documents. And this will take approximately 90 seconds or so, right? So I have 6 members in my coherence cluster. So it will parallelize the document chunking and ingestion. And you can see, I think okay, let me, my connection, let me refresh. So in that 90 seconds, so this cluster is running in OCI, Oracle Cloud. It's running in this Kubernetes cluster. Just trying to reconnect with it. And I can show you with a kubectl, it's running the 6 nodes over here as described. And it's still, still going. See some metrics here. Just to keep it alive. It's different pools. Okay, and let's take a look at metrics. And this is node state. So still chunking. Okay. Data distribution. Why is it taking longer than I expected?
So 20 years ago, every time I looked, there was
Yes.
frequently asked questions that they do. And
Yes.
for like a coffee shop, instead of chunking through all of this data with a mantra, that would be frequently asked question, or like when I look on the internet for how much potassium should I have in my diet, it doesn't have to go do that. So
Well, with the RAG, what you're trying to do is, let's say you have an FAQ. You're trying to give that FAQ to the LLM. So with that, if you try to ask a question that is answered in the FAQ and you ask the LLM, the RAG process will find the question that's closely related to your request. And in that process, it does the similarity search, it finds the document chunks, sends it in the context window along with your question to the LLM. The LLM at that point will return back the response, hopefully with the information that's from the FAQ.
and that's going to be fast.
Yes.
Super fast.
Yeah. So the example I had before with the coffee shop, right? it will do the similarity search. So, let's say milliseconds, and send it to the LLM. At that point, the LLM that I was using was ChatGPT. Again, milliseconds, right? Depending on your network latency. So the two network requests, and then coming back with your response. Let's say 100 milliseconds.
So all of those questions will get saved in the LLM.
No, it gets saved in the vector database. So it gets saved as document chunks in the vector database. And the parts that are relevant to your question that you ask, it will be sent within the context. Well, when you ask it a question, right, under the covers, it does the two things.
So that's what we want, because that is more accurate than.
Yes, because without the RAG process, it'll just make up stuff. Right?
Well, it could give a canned answer, like.
It'll try to give you an answer that it thinks, at that point, it won't have access to the FAQ. It will give you an answer that it thinks is best for you. But it might be making it up, it might be hallucinating. So that's the benefit of RAG. You're improving the accuracy, you're trying to reduce the hallucinations, and you're trying to do it in a scalable way if you have large corporate documents. That's on the order of potentially millions of documents, right? So this is taking quite a long time. This usually takes 90 seconds. Not sure what happened underneath me.
Yeah, it's going to be getting refreshed.
Yeah, let me see.
It knows it's being live streamed.
The demo gods.
Yeah, it usually takes about 90 seconds. And let me try to reset, which is just resetting is clearing out the ingestion. And I'll click on initiate load again. Yeah, so I'm not sure what happened. Let's try it again, and hopefully it should finish in about 90 seconds. So does that RAG process, is that clear to folks? It's a way to make things more accurate, and it stops them from making stuff up, right? So
Is there anything like multi-step or just a single step is sufficient?
So RAG has multiple parameters that you can. This is what I meant to iterate over that process. So that's the default process. There are other things that you can do with LangChain4j. You can do some kind of re-ranking of the documents and doing routing as well of the query. You might have multiple stores that you might want to use with different sets of data. But this is working better. It's elapsed time. It's yeah, it's what I expected. So yeah, that's what I meant by iterating to improve that process. You might have, let's say, PDFs that have graphics, like charts and graphs, right? That's very difficult for the LLM to understand. So you need to have a way to kind of textualize the charts and graphs in a PDF so that it's easier for the LLM to understand. So people have been making custom solutions for that. And you can plug that in. You might have a Java or a Python process to do that pre-processing of the documents, right? So yeah, there's a lot of things. There's a lot of things that you can fine tune and tweak as part of that process. But the general idea is you calculate the vector embeddings, and you try to figure out from there, okay, I have some documents that are related to your request. Let me go get the chunks, and I'll send it with the question to the LLM. The LLM will see it, and it's like, oh, okay, yeah, you already have the context here. Let me formulate a response that fits your question. So This is 160 seconds. What's going on here? So let me see. So this is, I'm using the RAG. It seems like it's sending out a response. One of the things I wanted to try that was the Bootstrap API. Where is the oh, here, this is the question.
Put those questions in.
So in the interest of time, I put in, you can type it in, but in the interest of time for the demo, I put it, this is just it's just the front end for a chat application.
Yeah, the chat didn't put the questions in
No.
itself.
No. It's just in the interest of doing the demo, right? I can say, you know. Right, tell me a joke. So it's something that is live, right? But what I wanted to show you was the difference, right here, was the difference between an application, oops, an application with RAG versus, hey. So once I type a message, does it, okay. I wanted to show you what the difference was in the response between with and without RAG, right? So I wanted to show you the Bootstrap. There is a coherence Bootstrap API that was added after 2021, right? So if I add it with ChatGPT 4, I guess in this case, it tries to give you what it knows about coherence, right? Pre-2021. And, you know, it's not quite right. If I do the same question with the RAG process with ChatGPT 4.0, you can see here, it's building the process and it's doing the coherence instance dot start. So I don't know. Yeah, it's if it's easy for you to for you guys to understand here. Whoop. But it's you know, if you look at without RAG, the example over here has hallucinations, right? There is no there is no kind of yeah, portable type that looks like this, right? So that's what I'm trying to convey over here. But I think the formatting was got a little bit chopped up here. Yeah, so with ChatGPT without RAG, it starts to hallucinate. So the code won't compile. It's just it's not correct. With the RAG that provides it the documentation to the product, it gives you the correct code, and it will compile properly. So what the other thing I was yeah, this is really strange, but this shouldn't be happening. I don't know why. But let me go back to the slides over here. Hopefully I can let me pause the sharing so I can get to, whoops. Let me stop the sharing for a second so I can get to the screen and then I can see the picture, the icon that I need to swap out. Okay, and then let me share again. So the benefits of using Helidon and coherence, I'll break it down with Helidon first. Helidon has a philosophy of trying to do things in the Unix style, in that, you know, simple things should be simple and complex things should be possible. It's a very small, very lightweight. It's much smaller than Spring Boot, and you can do you can certainly scale a lot higher with coherence. The time to first response and the memory footprint and the disk footprint is much smaller. It leverages the LangChain4j integration so that you have a nice API to use many different LLMs and vector stores and databases. You can use this in the context of a RAG application, the prompt templates and the chat memory management that is supplied by LangChain4j. The additional features you get from this combination, this integration, is that you also have the ability to work with Open API. There are tools that you can expose the API with. There's microprofile configuration. There's open telemetry. There's a lot of things that you can do with Helidon. What's also unique with the solution is coherence, in that it's a multi-purpose in-memory data grid. At its core, it's just a jar file, right, that you run your Java application with. And with that jar file, you can use it as a distributed cache. You can now use it as a vector store for massively parallel RAG, but also anomaly detection, recommendation engine, things that are facilitated by a vector store. You can scale from 1 JVM on a Raspberry Pi to thousands on the data center. Things are unique to the Coherence AI solution, has unlimited data types. If you use something like Postgres or any of the native vector databases, they have specific data types you have to use. This is Java, so you can use whatever data types you want as part of your application. It has distributed caching, auto rebalancing, sharding, and fault tolerance. It has the ability to do the querying, has the ability to do the semantic similarity search in parallel, has polyglot clients, but also the programming models. You can use GraphQL, their command line CLIs that you can use with CoQL. You can use Co-CLI, which is in the spirit of kubectl. And you have built-in observability, which if you look at the Python world, they don't have anything equivalent to JMX MBeans. So they always have to build the observability in. And if you follow the money, if you follow what the VCs have put a lot of money into things like LangChain, the group LangChain. And the LangChain product itself is open source, but Langsmith is proprietary license. So you got to pay for Langsmith, which is the observability platform. And that's where they make the money. So if you follow the money, observability is how they're paying the bills. So it's kind of interesting. With us, with Java, it comes standard, right? And we also, turn on open telemetry. Optional integration with any document store. So it doesn't matter what you can use Microsoft SQL Server. You could use anything as the backend persistence layer. Coherence will work with it, right? So, in conclusion, I just wanted to say it's a great time to be an agentic AI developer. There's a lot of things out there, and the things that we showed you, we hope you take a look at Helidon. There's some unique technical reasons why you might want to take a look at Helidon, and also why you might want to take a look at Coherence as well. So with that, that's That's all I got.
No questions on YouTube. Any questions? From anybody? Anybody? Did you sign in?
Probably not.
Okay, well. I have slides at the
Oh,
end.
okay,
If you
sure.
want to go back to.
Sorry.
So yeah, if you haven't signed in, there's a QR code to do so, folks, and I expect you guys.
We'll see you. We gotta run. Sometime.
All right. All right, so let's wrap up here. First of all, thanks Phil for doing that. At Java 1, there was a hands-on workshop to do pretty much just what Phil was demonstrating here tonight. It was pretty awesome. It was a sort of a step-by-step leading up to RAG. But the thing is, with the amount of time, I didn't get to that part. So, but if I remember, I'll try to send I think I can send the link, right, for that workshop. It's mainly, markdown files and, okay. So I can try to do that. But yeah, so just to finish up here. Let's see. Okay, so upcoming events going on right now is the Code Remix Summit in Florida. Well, I guess that discount code's irrelevant at this point. The InfoQ Dev Summit Boston is coming up on June 9th through the 10th. So you can check that out there. Last year, I was able to give away 2 free tickets. So I don't know if that opportunity is there. I'd have to ask. So then the Kansas City Developer Conference, or KCDC, is in mid-August in Kansas City. So if you want some great barbecue, then check that out. There's a 10% discount for that. Venkat has year number 2 of Dev2 Next in end of September into October. That is in Colorado Springs.
Beautiful area, if you haven't been.
Is it? I spelled Speens here, so I got to fix
Very
that.
beautiful area.
Is it? Yeah, I have not been out there. And there's others coming up. The QCon San Francisco is in November. JCon, which is going on right now in Köln, Germany. There's this effort that Richard Fitchner wants to do as part of the IBM exchange in early October. And so it'd be a sort of a JCon part of that. So I submitted an abstract for that. We'll see how that works. So, and that's in Orlando. I didn't put that on here though. Okay, upcoming events for us. So we now have 2 meetings in June, so next month. So as you've already seen, Elliot Rusty Harold will be with us to talk about bug-free projects. And if you've ever seen Elliot speak, he's really awesome. I first met him 25 years ago, and he's visited with us back in the old days in Scotch Plains. So this will be his first time here in Drew University. Then we have Anna Chernyshova, who will be here on Tuesday, June 24th, talking about testing GenAI applications in Java with test containers and Docker. The abstracts are all up on the website if you want to take a look-see at that. Billy Carando will be here. He's obviously, some of you have seen him before. He's also an Oracle employee. He's one of the developer advocate team. So he's going to talk about why developers should love testing. And also in July, this is kind of breaking news for Garden State Jug. Somebody reached out to me from Hazelcast, and we have tentatively set the following week to give a talk on Hazelcast. So I have to update the slides on that. So stay tuned for that information. So that's two meetings in June, 2 meetings in July, possibly. August.
We're not taking the summer off?
Well, August, we still don't have anything planned, but if you remember last year, next thing you know, we had two meetings in August last year. In September, we have a treat. We have a Vlad Shipovalov. Okay, so that's not bad for. So he's going to talk about Apache Spark and Databricks. And then we have Alok Tribruella. I don't think there he is. So he's going to talk about enhancing Java applications with LangChain 4J. So it's interesting. We hardly did any AI stuff until this year. Now all of a sudden we got a bunch. That's awesome. So that's both sessions are on September 9th. And the abstracts are on the website. October, Mark and Doug just left. I saw them last week at that Oracle Cloud event, along with Phil. And so we're kind of talking about October for having Mark and or Doug coming out. They were demoing something at the event last week. That was kind of cool. So,
So there's a developer sandbox that you can use for AI as well with the database.
okay, that's
It's quite interesting. It's kind of like what they built is internally we call it's the Oracle backend as a service, which is kind of like an opinionated stack of Kubernetes that you might want to use for your applications. And we also have it for AI as well.
cool. So yeah, so look forward to more details on that. So so this is great that we have all this stuff planned out well in advance. Some of you old enough remember the early days, Barry and I would look at each other the day before a scheduled meeting and say, hey, you got something? No, you got something? So that was, and then to be here like this is really awesome how we've evolved over the past 24 and a half years. So next year, we're going to try to celebrate 25 years of the group. So we should start planning that at some point, Paul. So, but yeah, so let's see what else. And then friends of the Garden State Jug, Andy Piper and Frank Greco are going to talk about autonomous AI for testing at scale and embeddings with LangChain 4J. Carl Chesser, open up your JVM with open source tooling at the Kansas City Jug. That's both on Thursday. And then let's see, the Boston Java Users ACM chapter, formerly the New England Java Group. They have Mia Longway to talk about AI Model Composition Protocol, or MCP, with Spring AI. And that was a exclamation point. Okay, not a second I. Yeah, the fonts get to be a little silly here sometimes. But and then Atlanta Jug on May 20th, enhancing developer productivity with Backstage. I've heard references to that, but I don't know what that is. But in any event, let's see. Oh, Don Robb is going to talk about divide and conquer feature-rich APIs at the Pittsburgh Jug, which is also on Thursday. And then the Chicago folks have Sean Sullivan talking about Amazon S3, and they're going to have some lightning talks over there as well. And this is on June 4th. And then Philly doesn't have anything planned until July 8th, the day before our meeting with Billy, but he's going to talk about lightning fast startups in the jar. So, oh, and IntelliJ IDEA winners for March and April, Ed Savage and Paul Lester were the winners respectively. So please fill out the attendance today so we can put you in for a raffle with that. And there's the same QR code that's printed on the tables over there. I didn't put out the stickers today, but if you want any, I have my bag handy right there. Again, thanks for everybody out in TV land for your patience in getting started. We're really hoping Barry comes back next month. So he had a conflict today, and so anyway, so we managed. That's the main thing. And so yeah, thank you. We'll see you in a few weeks. Take care.